Hello class, I am Michael Ryan. Welcome to my video log on the historiographical issues associated with my dissertation topic, the origins of quantum computing, the marriage of computer science and quantum mechanics. My dissertation is focused on the history of quantum computing from the beginning of the 1980s to present day. There were two discoveries by Peter Short Bell Laboratories that provided the momentum and investment funding required to establish quantum computing into the active research field that continues in the year 2023. The first discovery was in the spring of 1994, and it was an algorithm that proved that quantum computers could, in principle, solve a task of great cryptographic importance using exponentially fewer steps than the best currently known algorithms running on traditional computers. The second discovery in 1995 was the realization that quantum error correcting codes existed and in principle could make quantum computation fault tolerant. This meant that it would be possible to protect quantum information from what's called decoherence, which had been regarded up until that point as the chief obstacle to the eventual realization of quantum computers. So decoherence can be viewed as the loss of information from a system into the environment. So what does that mean? Imagine a coin that you flip and you have two options, heads or tails. Simple problem, simple solution. Now, if I take that coin and spin it on its side for a number of minutes, think about the multiple permutations of solutions while it is spinning. External factors cause noise or it stops the spinning. Those are the obstacles that exist with quantum computing. And those multiple permutations are the opportunity or the problems that can be solved by problem computing by looking at all the permutations. So that helps with problems such as encryption, drug development, simulating aircraft parts that could be simulated in minutes versus years. So key questions that are included in my dissertation topic is, how did these two discoveries by Shor resolve existing business and government problems not resolved by classical computers? Also, how has the historiography of quantum computing evolved prior to and after these events? Another question would be, how did these events result in business government funding and research? So the answers to these questions resolve current gaps in the history of quantum computing by linking the historical evolution of theory, physical realization of theory, investment funding based on potential business value, and the realization of business value. Currently, these topics are siloed topics in scientific journals and also in marketing material provided by quantum computing companies such as IBM, Google, and Microsoft. So the history of quantum computing up to date has been an area of limited exploration by historians. Academic works primarily consist of scientific articles focused on quantum computing theory and achievements related to the number of qubits in quantum computers built to date. The goal of these computers, known as quantum supremacy or quantum advantage, is to demonstrate the ability to solve a problem that no classical computer could solve in a feasible amount of time. So the historiography from 1980 to date may be categorized into two schools of thought when it comes to achieving quantum supremacy or quantum advantage. One school of thought I would categorize as the optimist. And the optimists maintain that a viable quantum computer is achievable in the next decade to 20 years. These optimists would point to facts such as the current $55 billion in state-sponsored research and development initiatives worldwide as of January 2023, so $55 billion in investment. The other school of thought I would categorize as the pessimists. And the pessimists maintain that a viable quantum computer is either not achievable based on physical limitations here on Earth, or possibly achievable well beyond the most optimistic estimates based on progress to date. And they would point to information such as a 2021 CEO study that 89% of the more than 3,000 chief executives surveyed did not cite quantum computing as a key technology for delivering business results over the next 2 to 3 years. So they don't see it as something that's going to happen anytime soon. The problem that I will help solve with my dissertation is tying together the history based on the facts around scientific achievement, and I'm going to correlate that to investment funding and business value to date, as well as expected business value. Now, there is no historical document that I've seen that provides answers to the questions that I've laid out with historical accuracy. If the optimists are correct, we'll have quantum supremacy in this decade. At a minimum, $55 billion in funding indicates that we should have a historical point of view on the key questions and answers around quantum computing. These are the historical viewpoints to be addressed by my dissertation. So thank you for your attention and best of luck in your dissertation process.